Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2019. This was a simple question from the topic of radioactivity and was based on single choice correct. I am sure most of the students in India would have done this question without much difficulty. However, I am going to tell you the most simple solution, or you can say the minimalistic calculation will be involved. So let's see what is being asked in this question. A radioactive sample of potassium is getting converted either into calcium or arsenic. The decay constants of both these samples have been given. They are assumed to be stable in the question. So calcium has a decay constant of 4.5 into 10 to the power minus 10 per year, and arsenic has a decay constant of 0.5 into 10 to the power minus 10 per year. It is also given that after a while, like this much time, so actually this is not a while, this is a lot of time. So after this much time, the total sum of the nuclei of calcium and arsenic, if we take the ratio of the total sum of the nuclei of calcium and arsenic to the total number of undecayed potassium, that is 99. That means अगर कैल्शियम एंड आर्सेनिक के टोटल न्यूक्लियाई जो प्रोड्यूस हुए हैं उसका सम के साथ हम रेशियो लें पोटेशियम के जो अनडीकेड बचे हैं तो उसका रेशियो इज 99. So we have to find the value of T using this data. Value of ln10 has been given to reduce the calculation. So very simple question, as I told you. First of all, we need to realize in this question that potassium, either it can decay into calcium or it can decay into arsenic, right? The decay constant of calcium has been given as 4.5 into 10 to the power minus 10. This we can call lambda 1. And similarly here it is 0.5 into 10 to the power minus 10. This is lambda 2. We know that when a particular radioactive sample or a nuclei, if it can decay into two possible products. So if you want to find the lambda of this, so lambdas are additive quantity. Lambda, we can find lambda equivalent is equals to lambda 1 plus lambda 2, right? Now also, if you see, let us assume that there were 100 nuclei of K initially. Now after time, let's say whatever we have to find that time. So after that time, total nuclei of this that would have decayed will be 99, because we can say if 99 nuclei of K has decayed, then total of this will be 99, because we are assuming one-to-one relation. That means if one of the nuclei of K decays, then one calcium will be produced, or one nuclei if of potassium, if it decays, then one arsenic is produced. So basically if 99 nuclei of potassium decays, then total sum of calcium plus arsenic will be 99. So if you assume that initial sample was n naught for potassium, so we can say that after the time t, we can say that the potassium left will be 0.01 n naught. This is the number of nuclei of potassium that would be left if initial was n naught. So we can just apply the formula. This number of nuclei left is equals to number of nuclei that was at initial time into e to the power total lambda, which we can say is 5 into 10 to the power minus 10 into time, right? So this will cancel out. We can take the ln on both the sides. So if you take ln on both the sides, it will become ln of 0.01, which will be equals to minus 5 into 10 to the power minus 10 into t. This you can write ln 1 by 100, which will become minus 2 ln 10, right? Because 100 is 10 square and 2 will come out using the property of log, right? So from here you can see that t comes out to be ln 10 value has been given. So that was 2.3 divided by 5 into 10 to the power 10, right? So if you take, I think the answer we have to quote in the form of 10 to the power 9. So you can take 110 from here and it will become 46 by 5, which is 9.2 into 10 to the power 9. So you can see there was not much calculation and a simple, elegant, crisp solution. So I hope you would have understood. That's all. Thank you.